Now, hello there. Here we want to do a question which is on modeling. It says a model for the population P of T in a suburb of a large city is given by the initial value problem this. So this is our initial value problem. Well, this is the initial condition here. And then we are told that T is measured in months. Now the first question you're asked to find is the limiting value of the population. That's the first thing you're told to find. So we want to find the limiting value of the population. And it says, at what time will the population be equal to 1/2 of this limiting value? So that's the next thing that we intend to find. We want to find the time when a population will be equal to 1/2 its limiting value. So precisely how exactly do we intend to start doing something like this? So the first thing you need to do is we have to solve this differential equation with the initial condition. So what we're given is the PDT equals P into 10 to the power negative 1 minus 10 to the power negative 7 times P. And then the initial condition we're given is P of another time T equals 0, the population is 5,000. Anyway, let's start by solving this differential equation. Now to solve this differential equation, we will observe that it is actually a separable equation. In other words, we could separate the p's on one side and the t's on the other side. So what you would have is the p all over p into 10 to the power negative 1 minus 10 to the power negative 7 times p equals the t. So the next thing is we integrate both sides. Now what you'll observe is we have, this is 1 all over p times 10 to the power negative 1 minus 10 to the power negative 7 times p. So what we have to do is to solve this, we have to resolve this into partial fraction. That is 1 all over p into this. There are two things multiplying. It's two terms multiplying. So to resolve that into partial fraction, what you would have is, after resolving that into partial fraction, is going to be 10 all over p plus 10 to the power negative 6 divided by 0.1 minus 10 to the power negative 7 p equals the integral of the t. Now this is what you get when you resolve this into partial fraction. So then the next thing is we integrate. So integrating this, we have 10 ln p plus, so we have 10 to the power negative 6. So there should be a dp here. 10 to the power negative 6. Then ln of 0.1 minus 10 to the power negative 7p divided by, so when we differentiate this, we'll have minus 10 to the power negative 7 now equals t. So when we simplify this further, what we would have is, that's going to be 10 ln p, then 10 to the power negative 6 divided by this minus 10 to the power negative 7. That's going to give us negative 10 ln of 0.1 minus 10 to the power negative 7p equals t. So there should be an arbitrary constant here, plus c. So then when we simplify this, what we're going to have is, so it's like we're dividing both sides by 10 now. So you have ln of p minus ln of 0.1 minus 10 to the power negative 7p equals, so we divided both sides by 10, so you have t all over 10, then plus, so c divided by 10 is going to give us a new constant, which we're going to call c1. And then using the laws of logarithm here, we have ln of p divided by 0.1 minus 10 to the power negative 7p equals t all over 10 plus c plus c1. So simplifying that, what we would have is going to be p all over 0.1 minus 10 to the power negative 7p equals, so it's going to be e to the power t all over 10 plus c1, which is actually going to give us a new constant b e to the power t all over 10 divided by 10. So we're still on the stage of breaking the whole thing down. So still on this, so what we have there is we have p divided by 0.1 minus 10 to the power negative 7p equals be. So t all over 10 is something as 0.1t. Now the next thing we want to do is to cross multiply, so you have p equals b e to the power 0.1t into 0.1 minus 10 to the power negative 7p. So then the next thing is we want to make b the subject, we want to make p the subject of the equation. To make p the subject of the equation, what you now have is, that is what I mean is the p here. So we want to bring all the p's here. This is a p, this is a p. So we want to bring everything on one side to make it the subject of that equation. And then when we do that, what we'll have is p equals 0.1 b e to the power 0.1t divided by 1 plus 10 to the power negative 7 b e to the power 0.1t. So this is what we had in finding the general solution of this differential equation here. But we're given an initial condition that says at time t equals 0, the population is 5,000. So let's implement this initial condition here. So it says when t equals 0, the population is 5,000. So using that here, so we have 5,000, since our p now is 5,000, equals 0.1 b. So e to the power, so wherever we see t, we have 0. So 0 times 0.1 is 0, and e to the power 0 is 1. So we do not need to write that again. Divided by 1 plus 10 to the power negative 7. And then we have b e to the power 0 is also 1. So our aim is to make b the subject of this equation here. So what we do is we cross multiply. So we have 5,000 into 1 plus 10 to the power negative 7b equals 0.1b. Then when we simplify that further, we would have our b to be equal to 5025 1.